Let's now differentiate some more difficult composite functions. Hopefully you've seen my previous video where I showed you guys the chain rule. We're now going to be using the chain rule without the substitutions, assuming you guys are a bit more comfortable with that process, okay? Because what I showed you in the last lesson is a technique which you do at the beginning when you learn differentiation, but you don't use all the time, okay? So differentiate ln of 1 plus sine x over 1 minus sine x. Now, if you were to use that chain rule process explicitly, you would let u equal what's inside, and then you differentiate that, then ln reciprocates, you'd multiply them together. But it's restrictive by following that process every single time because, like I said in the previous lesson, ln has some special properties because it's a log function. Students, when they default to just letting u equal this, they forget that when you divide within a log, you can separate this. It becomes ln of 1 plus sine x. Then ln division means subtract ln of 1 minus sine x. And again, you could let u equal this, or you could say, look, I know I need to differentiate this first. What does 1 plus sine x differentiate to? 1 disappears, and sine differentiates to cos. Then ln reciprocates the argument. It reciprocates the argument. Okay? Minus, let's do the exact same thing here. We differentiate the argument first. 1 disappears. Minus sine x goes to minus cos x. Divided by ln reciprocates the argument. Okay? Now we just need to clean this up. The double negative becomes plus. Then we can cross multiply and bring this together. Because on the denominator, these two multiplied together is just difference of two squares. We get 1 times 1 is 1, minus sine times sine is sine squared. Then we get cos times this, so we get cos times 1 is cos x, minus cos times sine x sine x. The double negative is plus, cos times 1, cos x. Then plus, remember this is all one big plus. Cos times sine is just cos sine. And then these cancel. Cos x plus cos x is 2 cos x. Then hopefully you notice with the denominator, 1 minus sine squared is cos squared. And then the coses cancel. We're left with 2 over cos x. Yeah, we could leave it like that, or we could write it as 2. Cos in the denominator is sec. Okay, so there's our solution for that one. Let's take a look at the next one, where it says root of 2 to the power of 2x minus sine 2x. So the first thing we need to do is we need to identify that that is a power function. Yeah, the root takes priority in terms of what type of function we are differentiating. Okay, so we're going to write that as bracket 2 to the power of 2x minus sine 2x to the power of a half. Now in the previous video I told you guys to let that equal u. What you would have let equal u, I call the angle, you differentiate that first. Okay, so let's differentiate what's inside the bracket first. We need to differentiate 2 to the power of 2x first. That's an exponential. It differentiates to itself. Ln of the base. But first, this isn't just 2 to the power of x, it's 2 to the power of 2x. Okay, so we have to differentiate that first. So 2x differentiates to 2 multiplied by exponentials differentiate to themselves. Then we have to multiply by ln of the base. Now guys, if you want, you can bring these two together. It's a pretty unique question in that sense. You can add the powers, 2 to the power of 2x plus 1. You don't have to do that if you don't spot it though. Minus sine 2x. How do you differentiate that? You differentiate the angle first. 2x differentiates to 2. Sine differentiates to cos. Angle stays the same. Okay. Now, I'm going to write this a little bit smaller. I'm just going to write it again. So when I bring this together, I get 2 to the power of 2x plus 1 ln 2 minus 2 lots of cos 2x. I'm going to protect it. Then what do we do? Remember, this is a power function, so we're going to bring down the power and then knock 1 off the power. 2 to the power of 2x minus sine 2x to the power of minus a half. Now that I actually noticed this half, had I kept this 2 here, I could have cancelled this half with that 2 and this 2, which I actually want to do now. So you can kind of backtrack if you want. I don't plan these lessons. I'll just reintroduce it. That half cancels with this 2 and this 2. And another way we can clean this up is this can go in the denominator with the root around it. So let's do a big fraction. So let's bring that in the denominator, 2 to the power of 2x minus sine 2x. Then that power half means that I have a root around it. Then I'm left with 2 to the power of 2x ln 2 minus cos 2x. And that is a beautiful solution, Mike. Next one, e to the power of 4e to the power of 4x. This one should be more simple. I usually say when you're differentiating e for easy. Easy. So if I have e to the power of 4e to the 4x, what would you guys have let equal u? You would have let the power equal u, yeah? So you differentiate that first. So forget about this. How would you differentiate that? 4 is just a multiplier. That 4 does nothing. Differentiate that. E to the power of 4x, you differentiate the power. 4x differentiates to 4. E differentiates to itself, and then power stays the same. Okay? So this here differentiates to 16 e to the 4x. So you differentiate that, it comes down, 4 times 4 is 16, e stays the same, then you have your 4x. Then remember we had this, okay? So what we essentially did, guys, is we differentiated the power, e differentiates to itself, and then the power stays the same. Okay, so this is literally just the differentiated power. And you write that down. What you would have let equal u, you differentiate that first and just write it down. Okay? So we are left with 16e to the 4x times e to the 4e to the 4x. Yeah? Can you simplify this? You can. Having these double e's doesn't look very nice. You can bring them together by adding the powers. You could have e to the 4x plus 4e to the 4x. Can you simplify that more? I mean, you can infinitely keep simplifying things if you want. You could factorize out of 4 maybe and say that is your final answer. Okay. Last one, ln x. My favorite function. Big up the Lun gang. If you guys want to submit your own questions, you can join the Lun gang Reddit page. Link is in the description. Now here, I'm going to write like this. We have ln of ln x. Because if we wanted to differentiate ln, it's ln of something. So this is the primary function that we're differentiating. Ln of this. This is what you would have let equal u. Okay? And that is what we would differentiate first. So I'm going to differentiate ln of ln x first. Because this is my argument. This is what I call the angle. So when you differentiate this, what does ln do to the argument? It reciprocates it. Yeah, so it goes over ln x. Then you differentiate the argument, and that goes to the top. Ln x differentiates to 1 over x. Okay? So another way you could have done it is you could have said ln x goes to 1 over x. Then ln reciprocates this. You could have written 1 over x. Yeah, so showing you guys different ways of thinking about this. Yeah, you could differentiate the argument. Ln x differentiates to 1 over x times ln reciprocates the argument. Which like this, it simplifies very nicely to this. Okay? So that is the differential of this. Okay? So my overall function is going to be write this down. Okay, that's the differentiated version of this. Then ln reciprocates this. So we're going to times it by 1 over this, ln of ln x. And there we go, we're done. So bringing it all into 1, we have 1 over x ln x times ln of ln x. And that is a beautiful answer. So guys, with this technique of understanding the chain rule, you can differentiate things as difficult complexity as you want. You can make stuff up and you'd still be able to differentiate it. Ln x is just something I made up 30 seconds ago. Well, a bit longer now. But if you learned something today, guys, I'd really appreciate if you hit the like button, subscribe for more maths content. And if you're interested in my A-level maths courses, there is more details in the description. I'll see you in the next video. Nice.